Hello everyone. As we have seen in our previous video about distance and displacement characteristics, and also understood that distance will be greater than or equal to displacement and cannot be equal to 0 and cannot be negative, whereas displacement can be equal to 0 and can be negative, right? So now in this video, let us try to understand about how to calculate or find distance at the same time displacement when a particle is moving in a circular path. Circular path means already we know that a path considered about a fixed point at some fixed distance, and that fixed point we call it as a circle, and that fixed distance we call it as a radius. So now let us assume there is a particle, and that particle is moving in a circular path as shown here. So in this circular path, let us assume the center of the circular path be some O, and now say its radius be some R. So the particle started initially, assuming that the particle started initially from position A, okay, and now when it started its motion or movement in the circular path from A, assuming that it is traveling through different points on this circular path, namely B, at the same time C, and some more D, and at the same time E. Probably it may reach back again A also. So assuming the particle traversing in a circular path through all these points. So when it reaches at different points, what is the distance and what is the displacement? So to find out this one, straight away we will have two different formulas, one each for distance and another one for displacement. Straight away we can find out the distance and displacement of a particle at any instant or at any position in the circular path at an ease. So let us try to understand this one. Assuming that an arbitrary point B be considered and the particle is reached, or a particle have reached position B after it start from A, assuming that the angle made by this particle at the center be considered as some theta. Clear? And already we assume that the radius of this circular path be considered as some R. So therefore I would like to mention over here R is equals to radius of circular path, and theta is equals to angle subtended at center, angle subtended at center. So one more condition you need to consider is theta, that is angle, always should be only in radians. So please remember this one, a theta should be in radians only. So now for point B, or at point B, so to find out a final formula or a direct formula, so distance traveled on reaching point B is equals to what I can say, length of the path traveled. Basic definition, what is it? Length of path traveled is our basic definition. So from above circular path, length of the path traveled means I would like to say length of arc AB. I hope you understood everyone. Length of arc AB. So that is nothing but the particle is traversing along this circular path, and this is nothing but arc only for us. So if we can find out the length of this arc, we can easily find out the distance between A and B, where it is subtending an angle theta at the center straight away. So length of the arc formula already we have learned in our childhood only. In mathematics, that is angle subtended at the center. Okay, angle subtended at the center by total angle in a complete circle, assuming in radians, that is 2 pi into circumference of circle. Circumference of circle is 2 pi into radius. So from this I can just simply cancel 2 pi and 2 pi. Thus the distance of the particle moving in a circular path for an angle theta subtended at the center is given by r theta. Distance is equals to r theta directly. So if the units of this one will be dependent on the radius. If radius is in centimeter, here distance will be in centimeter. The radius is in meter, distance will be in meter. And now assuming the same thing for displacement. Displacement S is equals to, so assuming this r is a one of a vector and this radius is also a one of a vector. So from the figure I can say displacement is the distance between initial and final position in a specified direction. So this is S. So therefore I can say here displacement S is equals to length of AB bar, length of line segment of length of line AB. So directly I can say AB bar. So using parallelogram law of vector addition, there are two vectors R and R in the same direction separated by an angle theta over here, separated by an angle theta, and then we need to find out this displacement S. So using parallelogram law of vector addition, one of this radius is assumed to be considered in negative way. So using parallelogram law of vector addition, if you need to understand about parallelogram law of vector addition, you can check it in our videos. It's already mentioned or explained there, parallelogram law of vector addition. Using that you can have a better idea about it. So from that, magnitude of the resultant of two vectors is given by root over a square plus b square plus 2ab cos theta, where theta is the angle between two vectors, a is the magnitude of vector a, b is the magnitude of vector b. So now here for us both the vectors magnitudes are radius only. So let us substitute this one, r square, and assumed one of the vector to be negative, so minus r whole square plus 2 into r into minus r into cos theta. So that is equals to, you can just simply write away this one as 2r square minus 2r square cos theta. So I can take 2r square common. From the trigonometry we will get 1 minus cos theta, and 1 minus cos theta takes the value of 2 sin square theta by 2. Since 1 minus cos theta is equals to 2 sin square theta by 2. Substituting in the given expression, we will get S is equals to root over 4 r square sin square theta by 2. So under the root we will be eliminating all the quantities which are double. Therefore S is equals to 2r sin theta by 2. So this is the formula for displacement for any angle theta. Now you might get a doubt, sir, why you have assumed one of the radius as negative? So using the triangle, I would like to explain in short over here. See, if this is depicting the same diagram over here, this is O, and here this one is your depicting this one as R, and here this one as r. And what we have said, this one, say this is a and this is b, and angle over here considered as theta. And we said that this is your displacement, right? S bar. So from the triangle of vector addition, if you say here this one, say this is r1 bar, b this one be r2 bar. From triangle of vector addition, two vectors taken in an order will be summation together to form a resultant taken in opposite order. So OB bar is in opposite order, OA bar and AB bar are in same order. So what you can say, this one as R2 bar is equals to R1 bar plus S bar. But what we require, displacement S bar. So S bar is equals to R2 bar minus R1 bar. Did you see here? In resultant we just got one of the vector in negative direction. So that is the reason in the displacement finding here I have assumed one of the vector magnitude to be minus r. So hope you have understood. So now let us see this one with an well-known example, like one of the point we will see to check these two formulas perfectly. So at C. So from the figure, if you see the point C here at the figure, directly you can understand that point C stands at an angle of 90 degrees over here. So directly I can say angle subtended at the center theta is equals to 90 degrees, and that is equals to pi by 2 radians. So therefore distance, traditional method, distance is equals to traditional method. What you can say, length of the arc traveled, right? So length of the arc means it is exactly 1/4 of a segment, I can say. So therefore distance is equals to 1/4 of circumference. Directly we can say 1/4 of a segment of circle. So therefore 1/4 of circumference is 2 pi r. So which results in pi r by 2 meter. Now from our formula, what we have taken our formula to be is distance is equals to r theta, and that is equal to r into theta is simply pi by 2 radians. So that is equals to pi r by 2, units assumed as meter. Both the answers are same, so we can use our formula universally straight away. And now let us see the displacement in this case only. So if you see in the above diagram, I would like to depict the whole thing over here once again. So displacement S. So this is your center O, and this is point C, and this is assuming point A. So what is our displacement? As we know, this is our displacement, right, from A to C. Sorry. So this is our displacement from A to C straight away. I guess it is not in a straight line. So let me take this one once again. Yeah. So this is our displacement from A to C. So you can observe this is a this is a right angle triangle. So you can use Pythagoras theorem to find out the displacement whose sides are r and r. So therefore displacement S is equals to, from the figure straight away I can say, root over OA square plus OC square, that is equals to root over r square plus r square, which results in S is equals to root 2r square, and then S is equals to root 2 times radius, and the units are assumed to be meter. This is the traditional method of finding the displacement. Now let us see the displacement based on our formula. What is the formula we have? S is equals to 2r sine theta by 2, and that is equals to 2r sine theta assumed as 90 degrees. So 90 degree by 2, which results in 45. So 2r sine 45 degree. Since we already know sine 45 degrees is equals to 1 upon root 2, substituting in the given, s is equals to 2r into 1 upon root 2, which results in cancellation to be of root 2 times r and meter. Again, it is clear that the answer is same in both the cases. So therefore these two formulas can be used directly. But remember, when you are finding the displacement in this case, you need to specify the direction clearly. S is equals to root 2 r meter from A to C. Here also root 2 r meter from A to C. Or else if you are good at directions, say this is east, already we know, and this is north. So therefore this direction of A to C, which will be representing root 2 r meter, you can say north east. Root 2 r meter north east. So hope everyone understood over here, right? So I would like to expect the answers from you all, that take a homework like thing. I would like to expect the answers from everyone who are watching this video. Please write your answers in the comment section, finding the distance and displacement at the points like B and E. So please write down your answers about distance and displacement in the comment sections at D as well as at E. Hope I can understand that you all followed the process or procedure clearly and you understood the thing perfectly. So please do it. Write in the comment section the answers for distance and displacement at the point D and at the point E as well. So I would like to add one more context over here also in this case, a note point you can say. Okay, so if a particle completes one revolution or one rotation, you can say, if a particle completes one rotation, then straight away distance is equals to 2 pi r, that is whole circumference, and displacement will be 0 because initial and final positions are same. Similarly, if a particle completes n rotations, n number of rotations, then distance will be n times the circumference, so n into 2 pi r, whereas displacement will be as usual 0. So kindly remember this one particular note point here while doing the problems of distance and displacement, that to a particle moving in a circular path. So hope everyone got the concept clearly and understood the point. So if any doubts, please leave a comment in the comment section, and don't forget to write the answers finding the distance and displacement of a particle at position D and E above mentioned example. Thank you all. Have a great day.